Good afternoon, one and all. I welcome you all to the day 4, session 3, which will be taken by Dr. Nidal Nasser. I must first of all thank you for accepting our invitation and getting connected from across Saudi Arabia, sir. Thank you very much. Given a brief bio of Dr. Nidal Nasser, he has received his BSc and MSc degrees with honors in computer engineering from Kuwait University, State of Kuwait. He completed his PhD in the School of Computing at Queen's University, Kingston, Ontario, Canada in 2004. He is currently a professor of software engineering in the College of Engineering at Al Faisal University, Saudi Arabia. He was the founder and director of the Wireless Networking and Mobile Computing Research Lab at Guelph. He is currently the founder and director of the Telecommunications Computing Research Lab at Al Faisal University. He has authored 180 journal publications, refereed conference publications, and book chapters in the area of wireless communication networks and systems. He has also given keynote speeches and tutorials in major international conferences. Dr. Nasser is currently serving as an associate editor of IEEE Wireless Communications Magazine, Wiley's International Journal on Communication Systems, and IEEE ComSoft e-letter. He has been a member of the technical program and organizing committees of several international IEEE conferences and workshops. Dr. Nasser is a member of several IEEE technical committees. He received Fund for Scholarly and Professional Development Award in 2004 from Queen's University. He received the Computing Faculty Appreciation Award from the University of Guelph, Hamburg. He received the Best Research Awards at various international conferences. He is the recipient of the Faculty Award for Research Excellence at Al Faisal University in 2014 and 2018. In 2017, he received 2 awards from IBM Mobile Application Developer Explorer Award and IBM Big Data Developer Mastery Award. He received the IBM Data Scientist Instructor Award for Educators in 2018. He also received the IBM Blockchain Developer Mastery Award in 2019. Sir, it is an honor and privilege to have you get associated with this faculty development program on blockchain technology. I heartily welcome you, sir.
Thank you very much, Dr. Bahar Gavi.
Yes,
it's a pleasure actually to be with you, all of you today, and we much really appreciate the invitation coming and the coming from the chair Achati, Professor Achati, and the also like all the work you are done for coordinating the the talk itself, and happy to share my background about the both technologies which is now trending and the research, blockchain, and the Internet of Things. So if I will allow me, I will share my presentation, and then we can start. I think you can see now the presentation.
Yes, sir. Yes.
So it's my pleasure, and my honor to be with you today and talking about 2 important technologies. And in my talk, I will try to address the point of merging between the 2 technologies, how the other one can complement each other. And this is we'll start talking maybe first about the blockchain, and then we move about the IoT, and we'll merge about the talking about the or tackling the problems which is as a result of the combination of the blockchain and the IoT technology. So in my presentation, my line, I will. It's good to definition, and the definition, my way of defining the technology, it's more on how we develop the technology, how we develop the solution. So it's not just a definition that I will put some lines and so on. No, we'll go like a little bit more details. After that, it's like a more introduction about the IoT, and then the tackling the merge between the blockchain and the IoT, and what are challenging become like available for us as the researchers and even as the to teach and address to our students between the blockchain and the IoT. I will conclude my like
Sir, we are unable to hear you clearly.
What enter for communication, which
Dr. Nidal? We are
Yes,
unable to hear you
can you hear
clearly.
me? Oh, maybe I should switch off the camera and check.
Yeah, correct, yes.
Yeah, maybe sometimes it happens.
Yeah.
Please stop me at any time if you cannot still hear me. Yeah.
Yeah, sure, sir. Sure.
Yeah. Okay. So if I will start talking about the blockchain technology, I will start what's Jenny Romty mentioned on the Think Forum in 2017. What's the internet did for communication, blockchain will do for trusted transaction. So this is give us like even a long view to or vision to what we are expecting from a blockchain. As a blockchain technology itself, I will start defining some terminology. Sorry, yeah, which is important to understand the solution. Once we start building a blockchain, we need to understand some terminologies before we understand the technology itself. One of important terminology that we use it in a blockchain solution is the asset. Asset, something that it has a value, and this is, can be like something that it's physical, can be touched, or could be a service. This is what we mean. Who can exchange these types of the asset or the that which has a value? This is what we call them the participants. And participants are members. Sometimes we refer to participants as members, as peers. All these are the same, terminologies. We use it for the same meaning. They are the main members of the solution, blockchain solution network itself. Once we start, these participants start to exchange the asset between each other. This is what it's generate what we call the transaction. The transaction, to be valid, it should be following a specific agreed conditions and terms between the participant. And these what we call them the contracts. Maybe I should use maybe the laser pointer. Yeah, this is the contracts here. And the other part, which after everybody agreed and approved the transaction, then we have to save it. The saving a place, which is permanent place, this is what we called it the ledger. And these are maybe the main concepts that I need to start with so we can build on. I would like to start with an example, and this will be just like the starting on, and I will build everything then after that, even the development based on this. Car leasing life cycle. So if I will look to who are participants or who are the members involved in any car leasing, it started from the government, which is represented as a regulator, then the manufacturer, dealer, leasing company, and let's see, like me and you, like we go and just like open an application and buy a car or lease a car, and the car will end up with this scrap merchant. So in this case, our participants or members are the what I mentioned them here, and our asset, where we exchange the owner, for example, this is one example, the owner of that car, it's the car itself. So in terms of the government, they will regulate and create the registration. A manufacturer will add to this the make, model, and the what we call it, the vehicle identification number. Dealer will buy the car from the manufacturer. Leasing company also will buy the car from the dealers. Now me and you will lease a car from the leasing company. At the end of the life of the car, then we just dispose this car with the scrap merchant. If we think about it, all these participants during the life cycle of them, all of them, they will have each maintain their own information about the car. And if you look into this slide here that I mentioned it even a different color, it means independent. Let's just call them the database or the ledger of each participant. This is unfortunately may lead to a situation that a network of different ledger, each maintained separately by each participant. So maintaining up-to-date information exchange between these participants, I consider it to be expensive, time-consuming, and even may introduce a lot of errors, because each one it's independent, maintaining the records of that it's for that specific asset, which is the car, and even making open to making open holes, which is easy to attack or hack to the system of that specific participant. At the end, this will be translated hacking the whole network itself. So the solution, it's a blockchain. And the blockchain in this case, where we have a shared ledger, it's only one ledger that we will maintain all the record of transaction and the asset information. And before we keep any transaction on the shared ledger, it should be approved and validated by what we called the smart contracts. Smart contracts is again it's defined the services that we allow me to access the ledger and the condition for the asset transfer itself. As we can see, in this slide, we are creating only one shared ledger, so any transaction between the participant will be saved on that. However, to maintain a same ledger for each one, this will be under what we call the triplication. So it means if I am in the shared ledger, I am committing or saving a transaction. At the end, this transaction will be duplicated in all participants. So in this case, we will have a consistent information about what's happening in the network and between all the participants involved. Blockchain is a promising technology. It's not, so far, it's not just developed for a specific sector. It can be used with the different types of sectors, starting from financial, public sectors, and even medicine. I'm working now in a project involving using a blockchain with the pharmacies, and could be in the retail, supply chain, information sharing, suppliers, and the trial technologies, which I will focus one of the technologies today about the Internet of Things and how blockchain can help to overcome the challenges of the Internet of Things there. Manufacturing, again, this is another sector where blockchain is a promising solution to be used with. So if I will define briefly now, after this a brief introduction about the blockchain, I will say it's a distributed, shared, replicated, and permissioned ledger. So at the end, these are the key words that we always use it with the definition of the blockchain. Blockchain, it has 4 key characteristics, and starting with the shared ledger. And the shared ledger, it's a single common trusted among all the participants, where maintain all the records of the transactions. Smart contracts, something between, let's say, that the manufacturer and the government regulator, they have a specific conditions to meet in order for me to own the car. So these are what we call in the terms and conditions for the in the blockchain concepts. And we have the privacy. Not all the participants in the network should be able to see all the transaction. Whoever only involved on that transaction will be able to see that specific transaction. Accountability, this is something will be give me able to trace all transactions happening. Not only the trace of a transaction, but also will allow me to trace who is, for example, the first owner of that car that I did the ownership transfer for that car. So a little bit more details, I will go like here. If I will take the shared ledger, the shared ledger itself here, it's the where we save all the records of transaction between all participants. It's only one place. It's immutable. It means once we add to the shared ledger, we cannot update, we cannot delete. So this is what's make it also more accountable. And the other things that it's also once we commit a transaction or save it into the ledger, it means can be replicated. Replicated means the same copy for all participants, they will have it. This is just an example in terms of from point of view of developing the shared ledger. Think about the shared ledger as a data structure, and it's a linked list of blocks. Each block will be here like represented as just a set of transactions. There are a set of transactions on each block, and each block connected to each other by what we call it a type of hash function to make it more secure and more even trusted here, like in terms of. And out of the shared ledger, if I am handling, for example, like the current owner of a car, yeah. Always out of this ledger, I can get who is the owner of that car, the asset of that car, by what is the value of what we called it the word state. It's a variable. It's just a variable that will give me the last value it's assigned to that specific asset. Another example, I can just let you also understand this concept. It's suppose that you are opening your bank account. Once you open your bank account, you will see like on the dashboard, it's your balance. The balance here is represented the word state. If you like to see more what's happening on your account in terms of transaction, you will see all the list of a transaction, and this is the list of the blocks. How it's implemented is just a linked list. More will go like in terms of the smart contracts again, like it's a business rule that is associated with the transaction. Example again, like if I can define what are the lure which the vehicle can be transferred to a new owner. And in these rules, maybe not all participants are involved, maybe just a specific participants. Let's assume the manufacturer, the dealer, and the government. So who are these three participants will write some kind of conditions and terms. If the lessee, which is like me and you, that can be able to transfer the car under his name, then it has to meet the condition that is defined in that specific smart contract. In terms of privacy, again, like a ledger is shared, but not all like transactions are accessible by all participants. This is I will talk a little bit more later about it. This will be implemented in what we call the channels. So it means who are involved only on this transaction to validate this transaction and make it commit to this transaction, then they will be able to see this transaction. How this is implemented by assigning a different channel, and the channel will be represented by initiated like a kind of what we call it the chain code. Another interesting key characteristics of the blockchain, or what we call the accountability. How can all the participants do an agreement, or what we call or reach to the consensus? This is what we can be implemented as algorithms. There are different algorithms which I will talk about them. Out of this agreements and the accountability, this will allow me to even know the history, as I mentioned, of the ownership. Who are the first one on the that specific vehicle, and who is the next, and so on. I can keep tracing the ownership until the current one. Again, like accountability, we should always remind ourselves in a blockchain, the ledger is immutable. It means cannot be modified or inserted or even deleted. And finality, it means it's only one place to commit and save the transaction, which will be the shared ledger itself. I like here to highlight something related to, or I will call it confusion, where a lot of people, they think Bitcoins, it's blockchain. No, let me clarify something here. Blockchain, it's a technology that it's having infrastructure. On the top of this technology, we build application. One of the application which is built, it's the Bitcoin. And this type of the application, what under one category of the blockchain network, which we call the unpermissioned. Unpermissioned, it means there are many public. It's public that it means can be used by anyone. Our focus, or my focus here, it's more on permissioned. How can I develop a permissioned blockchain solution? This is what we will talk about it more on the coming slides. So if I will start thinking about how can I develop, there are many like now platforms which is available to build the blockchain technology solution. One of them, which is I selected for to talk more about it, it's the Hyperledger Fabric, which is part of the Linux Foundation projects, and it's open source. And part of the Hyperledger, it's also the Hyperledger Composer. Both these platforms will help me to develop the solution itself, given sometimes now they focus only on Hyperledger Fabric and the replacing of Hyperledger Composer with a different like toolkits or development kits, what we call it, the development kits itself. So if I will start talking about the solution now on how I develop it, I start with a Hyperledger Fabric, which this is the core where I do the implementation of the ledger, the smart contracts, make sure the privacy and all the agreement of the consensus algorithms are implemented on that part. To use this network, this is the core, yeah, the Hyperledger Fabric will allow me to build the core network between all the participants, even like having all participants part of the solution. To allow me now to access using different business application from outside of the network itself, we will use the Composer, Hyperledger Composer, or many different algorithms, what we call the development kits that I will maybe just mention it quickly in general about the different available like development kits with the solution of blockchain. A good blockchain usually will consist of 3 layers. The first layer is the data layer, and this is which include the main. This is the core, which include everything implemented in the Hyperledger Fabric. And there are components here, what we call the ordering service and peer and committing, even like committing like peers. And in addition to this, the certificate authorities, which allow participants to be part of the network itself. This is all in what we call the data layer. On the other side, we will have a business application layer. And the business application layer, this is which allow as an owner for business to interact with the network, the blockchain network. And so you can consider it, it's just including the application servers that host a specific application that can be accessed by users. And once this is allow me to introduce you to the last layer here, which is the presentation layer, which includes the user application. Example of this, just I'm opening my mobile application. I'm accessing, let's say that Toyota. I'm not doing like advertising for Toyota, but just an example. And this is, I'm accessing the application where the server where hosts this application on I use it in the mobile. To start building my car. I like this option, I like this option, I need this color, and so on. Once I commit, it means I want to purchase, I will press the purchase button. Purchase button now will send my purchase order to the network itself, the Hyperledger network itself. And this is what I will go in details and how we implement this. As a part of the blockchain also, we are expecting a blockchain solution to be enterprise solution. So will runs in the contents of a larger enterprise IT landscapes. And this may include a front-end application, as I mentioned, could be a device, mobile device, could be IoT device, that is, we may use it. In addition to this, we may introduce the middleware components, such as microservices or API management and gateways and so others. So this is something that we have to keep in our mind, that if we want to make it more enterprise solution. Blockchain having many components. I can go like on the in the more details on in details for each component, but at least I cover the most important component that we need to understand the implementation of the blockchain solution or network itself. So in terms of ledger, smart contract, peer network, which is again like it's consists of the participants or peers that is having the or performing the network itself. Membership, not everybody can be just part of the network itself. It have some kind of membership, and this membership is related somehow to the what we called it the wallet, because we may have participant or business, as I mentioned, enterprise from outside that can interact with my solutions and the solution that the blockchain solution which we build it. Many other components, maybe through my presentation, I will talk about them, but yeah, one important point, which again, like I focus on, as I mentioned before, how privacy is implemented through different channels. And as you can see here, for example, this is just, I put an example, participant or peer 0 and peer 1. They are working on listening, for example, let's say that it's by on the same channel which have the red color. What does this mean? They are involved in committing or validating a specific transaction on channel red color. However, P0 having a different channel also, which is the blue one, which will be different from allow P1 cannot see what's here transaction are validating. This is a kind of how we can privacy implemented among the participants themselves. So it means at the end, what I want to say that it's not all participants will be able to see all transaction in the shared ledger. Even they have duplicate, but they cannot have an access unless they have the same channel for validating and make sure this is a valid a transaction. And how this will be achieved by kind of what we call the chain code, which is will be initiated for each specific channel based on what we called it even sometimes the endorsing policy, which I will come to this soon. Again, as we mentioned, accountability is important, and to make sure that all participants are agreed on that specific transaction, we need to implement kind of consensus algorithms that make sure that all the participants, they are agreed on that. Why we have different algorithms for agreement, and the agreement that will be like selected based on the applications. For example, I'm just give you here some examples here. A proof of work. Proof of work is used with Bitcoins. It's slow. It has some, in the next slide here, I can show you like some pros and cons. Works in untrusted networks, but it uses much energy, and this is make it slow to confirm the transaction. So Bitcoins, if for your information, that may take like around maybe 10 minutes to validate and commit one transaction itself. So there are other algorithms which can be used, as I mentioned. If I am concerned about the fault tolerance and so on, then there is another one which I can use it. The CAFAC and Zookeeper. This is efficient, will give me efficient and fault tolerant mechanism to handle the transaction. However, it doesn't help me on blocking malicious activities and the network itself. So there are, as I mentioned, pros and cons. So at the end, you have to come and select which one it can fit with your application to be used. None of them maybe work for your application. It means we have to develop our own consensus algorithm that can be implemented with the blockchain, because it's important at the end to select the participant who can agree on a specific a transaction. In addition to that, another way of looking into what algorithm we can select, it's looking into the trade-off between, for example, my network K may scale up and increasing a number of nodes as we the business going on and on. So in this case, latency become an important point that I have to consider. So this graph is showing me the trade-off between the latency and scalability between the different types of algorithms, consensus algorithms that can be used. So this will help me, in addition to pros and cons, also will help me to understand maybe this the optimistic BFT, this will be hyper BFT or whatever that will be good for me to be used. So what I will do next is to go through with you the life cycle of a complete transaction. And it's more of four maybe examples here, or sorry, four steps. In general, this is an overview, high-level view of a transaction. The details will come later once I am going to the implementing the complete consensus steps, how we can at the end commit a transaction to the shared ledger. So a client like me, Nidal, orders a vehicle by using a vehicle buying mobile application, for example, and select the model, select the option, select everything related to the car. All what I needed now is just click the purchase and the button. This will be a transaction that will be submitted for the network itself through the, and I'm accessing the application through the server here. Maybe it's not included, but at the end, the server will send the request or the purchase request to the network itself. The network itself, there are some peers, or what we call the endorsers and committers, that will be validating my transaction. For example, not all the participants in the network of the car, vehicle, like example I gave, will be part of validating of this transaction, but part of them. After that, after validating, it will return back to the client. Your transaction is valid, Now we can submit it to what we call the ordering service. Ordering service, all what is do is just collecting the transaction, send it to committing peers. Committing peers will validate the endorser's signature. They will sign this is valid, and then they will just save it in the shared ledger. As I mentioned, this is just an example, starting with how it's implemented, the implementation. The transaction itself is just like as a function. I'm just calling a function invoke here, where I have some parameters. One of the parameters here that I will pass it with the transaction, it's what's the smart contracts, or what's the rules that I have to check on that specific transaction. This is what's represented by the set owner itself. So if I look in details of the set owner itself, this is it means the smart contract implementation in terms of the any business terms or condition that we need to check. At the end here, that it's other like parameters that will be saved to just make sure that it's the owner for my car now. It's to be the after it's committed and saved and the shared. This is if I will query the word state, which is this is, as I mentioned, equivalent to the balance bank account. This will give me this car is belong to. This is again like it's an overview of the a transaction life cycle. More details, it's now on the how the consensus of this transaction from beginning submitting from the user up to store it in the ledger. It will go through 3 different steps: the endorsing and the ordering and the validation. So the first step here, like as I mentioned, like the request, the client will propose the transaction. It's a 7 steps. There's more details here, as I mentioned. I will start with the first one, which is the client will propose me as Nidal propose transaction to buy a specific car, and this will be sent to specific peers and collect their endorsement signature. And on a specific policy, so there is a kind of what we call the endorsement policy that should be like implemented at this stage. Yeah. Endorsing peers, it's just participants from the network. As I mentioned, like maybe on purchasing a car, only the regulator from government, the manufacturer, dealer need to be involved. So it means these are the peers that I should receive the transaction. They will execute at this level or this step a smart contract. Make sure that all the terms and conditions are met in terms of these types of the transactions. The next, there are different types of endorsement policy, and usually we define them using the logical operators. For example, I want the manufacturer, regulator, and leasing to all of them, and I'm using and all of them to validate this transaction. Or I can put like or one of them validated. It's enough to make sure this is a valid or sign. We say that they sign that specific transaction. Or could be any type of combination of any logical operator that create endorsements policy itself. So in this example, I have E0, E1, and E2. Based on the endorsement policy, all of them should sign. It means and. I am using and here. So once they receive the transaction, they have to run a specific smart contract and make sure that this transaction is valid based on the smart contracts. How they will assign that specific like contract or sign that specific, this is something it's implemented through a different system. After they sign it, all of them, they agree, they will do like signing the transaction itself. And this will be done by what we call it endorsement system chain code. There is like a kind of what we call it RW set. So it means the endorser or the peers, endorsing peers that involve on that specific transaction will do a setting value for R and W, which is the read and write. This is what we called it. And this will be encrypted in terms of what we call the endorsement system chain code. Who will be able to see this? It's only the committing peers on the last step. So the application now will receive back the responses from, as you can see, it's received back here, the responses from the endorsing peers. Once they receive it, and it's considered to be a valid transaction, there is no, like all of them, they agree. The next step, it's a client only, me, as I already received approval on this. The system itself will send it to what we called it, the client will submit transaction to what we called it, the ordering services. Ordering services node itself here, it is just like just part of implementation of the system itself. If we look carefully to this, it will not do anything in this like solutions. The ordering service doesn't hold any smart contracts. It doesn't hold any like endorsement policies. The main work, I can summarize it, the ordering service is collecting transactions from different clients in a parallel way. So in the same time, they may receive different transactions, different like channels. And all what they do, they create what we call the blocks. The block itself now will be transferred to the other part of the solution, which is the validation. So responses submitted, the client submit endorses responses as transaction to be ordered. Ordering, all what they do, it's in receiving, as I mentioned, the parallel like transactions from different clients, and all what they do is just like deliver to the committing peers. Committing peers now will be able, like this will be the last step, which is the validation. We will do the validation now. We run validation and update their copy of the blockchain of the word state. And this is usually, well, after committing and save the transaction on the shared ledger, will generate a notification. Notification will be sent to the client itself. If it's having subscribe to this type of notification or not, this is something else that can be done by a different setting for the client if we want to get a kind of notification or not. Committing peer will validate that the transaction it's already approved by the endorsing peers by running again a different system here, validation system chain code, to make sure this is valid. They will check the setting for the R and W values, and it means they will somehow will see this is signed already. It means it's a valid, and at the time will generate a specific chain code through the validation system code and assigned or attached to the that specific block, and it will be like at the end saved on the ledger. This is the in general, like I'm not going in the more details on how this is happening, but I'm just giving the overview of how this is the committing of a transaction in the ledger itself. So the committing peers validate the transaction, and the application can register, as I mentioned, to be notified, and application are notified by each peer to which they are connected, and this is if they are like registered to be notified. By this, we consider this is it's a complete like a transaction of consensus, and which is involve the three different types of the three different steps: the endorsing and the ordering and the validation itself. blockchain, it's a solution. What you see here in the middle, it's the solution itself. It's involve everything that it's the participant, the ordering service, the committing peer, the endorsing peers, everything here. However, like sometimes we want to interact with the outside or external system. I will give you an example. If I am purchasing a car and I can't pay cash, so it may I want to, in my application, when I'm purchasing a car, I am putting some information about a mortgage which is approved by my bank. So the committing peer need also to interact with my bank to make sure this is a valid like mortgage confirmation. So this is in this terms that it means we have to interact with outside or any business like that it's working with the participants from outside that they want, for example, to query about a specific asset. So in this case, I need again like a different system from outside that it can interact with my. How we can implement this interaction, for external application system to blockchain in our solution, as I mentioned like before, there are the core, it's the Hyperledger fabric, which is create the network itself. However, from outside, Hyperledger Composer, but it's not more like now used. It's now more on software development kits where we can do it, or REST APIs. We can use REST APIs to develop these types of the application, which allow me to interact with the network itself. And this part, it's actually under what we call the integration tier, part of the important tier actually in developing any solution. Because again, the idea, yes, I have a trusted now information inside my network, but also I should be able to make it available from outside for different reasons. As I mentioned, example like validating my mortgage from my bank, query specific asset in the network from my business partner, sending events, which is events here also could be notification, a type of notification that your transaction is valid and saved in the ledger. All these will be like a kind of information needed to be done at that level. The other part, which is I may also talk about it in brief. I will not go in details about it. It's the security. Once we talk about security here, security should be implemented on a different level of my solution. I am not a security person. I don't have the good background, but I just included here for who are interested to know more where we should address the security issues in a blockchain. In a Hyperledger, the core, this is the solution. What I want to secure and how can I secure it? I also included here. Giving that also my presentation, I think it's recorded and it will be available. So this is good for who is working on this area to come back and understand more about the security level. The other level, it's the Hyperledger Composer, which I consider it maybe in some solutions so far, we are going a little bit maybe far from using the Composer, but in case still, if any solution using the Composer, these are the levels where we have to address the security. The other one, it's the platform itself, where we should make it more secure and how we can make it the security. The next part of my talk, it's now we understood very well the blockchain technology and how it's promising, how its characteristics, which is distributed and shared, and it have a specific ledger to share all the transaction among all the participants in the network. I will move a little bit now to the next technology, which is I want to introduce it to you briefly, which I'm sure maybe most of you are aware of this technology, the Internet of Things. If I would like to define an Internet of Things, it's a global network infrastructure, and this will link the physical virtual object through exploitation of data capturing and communication. This will be involving a lot of internet, mainly any types of network development like 5G, 6G coming, or 4G like before. This can be Wi-Fi. All these types of networks is involved. And to offer, like, we identify, we sense and connect capabilities with that will at the end develop what we call the services and the applications. IoT is promising also, and by now this year we are expecting like even up to 200 billion devices will be connected by the internet, by the concepts of the Internet of Things. It's not focused on a specific sector. You can see here, like, this is just an example that it's all are increasing in terms of the the device, the growth that it will be used in different sectors, in enterprise, in government, infrastructure, in home, and different like applications that we can use it. We consider the IoT, if I will check the components, infrastructure, it's that we have devices or objects that it can identify, sense, and communicate, and sharing the data. The data could be shared in coding, like with a high quality collaboration. Out of all these data will generate services that it has a value and also some kind of access right and delivery to the end user himself. So I consider the IoT is not a single key player. It could be, it should be, we look into this, it's not just a sensor. It's a key ecosystem, a complete like ecosystem that is starting from a semiconductor where we have very sensitive sensors that can be used in terms of the hardware, like different platforms that we can use it, in terms of software that we have apps and middlewares that can be used. And these all will generate, as I mentioned, like these services. So again, it's a complete solution, many like key areas that involved in this. It's not only what's always in mind, it's a sensor and a network. No, it's a different like point of view. We should understand it. Many applications developed, maybe I'm listing some of them, in industrial automation, home automation, smart grid management, conceptual social services, health services. I will just give a quick examples, like starting from at your home. Nowadays, even like starting from the main door, that you have a smart lock connected with a motion sensor. The motion sensor even connected with the smart lock itself, connected with the camera. So once we enter, like I want specific appliances to start, for example, the air conditioner to start, or even before I come just to the door, it to start the air conditioner. Different appliances that give me like different information about the energy consumption. It's not only in the house itself. If I will go back to the backyard of my house, a gardening system, I can having an efficient gardening system in terms of that allow me to know when I should water the plants. And this will allow me to save a lot of, for example, water. I'm not just consuming water as many that make my bill like to be high in terms of the payment itself. Other examples, it's from home coming to the building itself and the building to the city. Now we have many solutions that are like in a building or even in the smart cities under the concept of a smart city, that it has, for example, a lighting system in the street or on the building itself, working on the motion of the sensors itself. And based on specific data that we collected from different systems in the building or the city, could be like saved on a cloud and analyzed. Different like applications now we have in the shoes, like our shoes, that we have sensors that allow me to give me some information on a track of my like exercises. Not only on the shoes, but also on my wrist. In my wrist, I have now smartwatches that also give me like more information about my health, a kind of health measures, and others like related to the activities that I'm doing every day. Another, like in terms of if I will focusing on a health, the idea is just whatever device we are using, we capture the data. The data automatically will be through different types of network communication. Could be Wi-Fi, could be Bluetooth, could be whatever the type of the network we are using will be saved on a cloud. The cloud could be from end user, be access this data, analyze the data using any, whatever we could say it now, intelligent solutions in terms of deep learning, machine learning, to get more wise decision on about my health. And even I can visualize the data that I have it through the whatever devices connected and give me information about my health. Another interesting example, I usually also, this is what we call it a real scenario. And this will allow me to even like in a situation like far areas and in bad weather, that I don't need the actual, especially for elder people or disabled people, they don't need to go and do an actual visit for a doctor for a checkup. A sensor that is connected either to the person or to the house itself, like in a setup in terms of camera, visual sensor that can be used. This will give me more conditions about the health, give me more like information about the health condition of the patient. So this information can be saved and on a cloud and can be shared with many participants. Could be a doctor, could be a family member, could be even a hospital. And not only that, could be shared with insurance in terms of like, let's say that I have a claim and I want to get approval. Insurance automatically, they based on the data that actual data, these are actual data that are saved, can be also access these data and validate or approve this request or not approve it to save time for the patient. Another interesting like sector where we use like the Internet of Things in our cars. Nowadays, I can tell like from this one of the sources that I am including here, that around 6,000 plus sensors in terms of hardware and software and middleware that it can use in our cars. And the new like brand cars, including the electrical cars themselves. It's a promising technology, IoT, and usually in any different IoT, there are different way of how the systems are working. I classify this IoT sensing system working on a 3 different like architecture. One which I called it the centralized analysis, where the data on the left hand here, we have types of what we call the sensors and could be actuator. Actuator, the one that sensors, it's collect data, the actuator to do some actions based on a decision came from like different other systems. So in this case, the data will be collected, will be analyzed, saved and analyzed on a centralized location. Based on this like analysis, they will send the specific actions to be done on the actuator devices. This is one architecture of how it works. The other architecture, it's a data-oriented IoT, where it means all the data that we have, it will be saved on a specific like database or ledger. And after that, it means there are kind of subscriber to this data, they can query and get some responses. And these responses can even like generate a kind of events that will be translated into and actions to the actuator to apply. The last one architecture that it's the some specific data can be collected from a specific area that these data, if we save them, this is will be generating what we call a specific service. So it means I have to subscribe to this service. I have to pay for this service to get the benefit of the data that is collected for that specific event. Still, as I mentioned, it's a promising technology. However, this technology is still having many challenges to be considered and solved. IoT, let me just browse maybe all of them and talk. IoT solution will generate, we are expecting, if we say that 200 billion devices just by this year, end of this year. So we're expecting more and more of devices that will generate a huge amount of data, which need powerful, actually, platforms to store, manage, analyze, and even make sure they are secure. Many IoT solutions are still expensive, the current solution, due to costs related to deployment and maintenance of centralized clouds and server farms that are the core of the solution itself. And also sometimes it's in terms of privacy, it's difficult for IoT users to trust technological partners. Why? Because sometimes these partners, they give the certain authorities like to governments or even service provider to share my information as a user. This is make my privacy at risk, my privacy and your privacy to be at risk. So all these are challenges, and I propose in this talk IoT or asking the question, is a blockchain technology solution for IoT could be the solution for IoT challenges. Based on if I will collect the IoT challenges and the blockchain characteristics, I try to manage or merge between them, both of them, make the characteristics as a solution to the challenges of IoT. And this is what I will present on the coming slides here. So decentralization is still like a blockchain. If I will think about decentralization of the blockchain characteristics, this will offer the effective mechanism to change IoT centralized architecture to peer-to-peer distributed ledger, which in this case, we make sure that its scalability, robustness are ensured, and also eliminating the consensus many to one traffic flows. Also, this will allow me to decrease the latency and solve the problem of single point failure problem that exists currently on most of the centralized models. Immutability, again, it's one characteristic of a blockchain, and this will make it ledger. It's immutable. It means now I can have more secure and the privacy for IoT system on the ledger, which is I cannot change any transaction. I cannot delete any transaction. In terms of access management and identity, blockchain can implement trusted distributed authentication and authorization of devices in IoT the application. Reliability, it allows me the blockchain to trace. As I mentioned, accountability, it's important here, where I can trace billions of connected devices and make sure they are there and follow all the transaction process happening on the network itself. So I know who will be having the problem, which one having the problem, one allowing for malicious to enter the network itself. All this information could be through the accountability under autonomy, that a blockchain will allow me to automate the operation of the Internet of Things solution, because at the end, we can validate and make sure that the transaction is valid based on a smart contract. So I don't need a human interaction to validate it. It's based on what we implement. We can be considered. The other thing is the cost saving. And the existing available solution, as I mentioned, expensive. It has a lot of high infrastructure and maintenance costs associated. A blockchain will allow me to just make it more less cost in terms of maintenance. Just consider that I want to update a firmware of a specific sensor. So it means I have to send it for the million devices that I have them, or a billion devices that I have them. The other important characteristics that offered by the blockchain is the security. Again, security blockchain will allow me to exchange IoT messages and transactions and validate them by smart contracts. Other than that, it will also provide a secure platform for IoT devices by providing massive amount of trust. Since the majority of participants in the network had to reach an agreement to validate any types of the transactions. I can tell this is the future. It's become a BIoT. I called it a BIoT application. And again, like this is, it will not be for a specific sector. Can be used with the different sectors and application in agriculture, in the transportation and health and smart cities and energy, government, defense. All these will be like application that we can develop. So if we be able to develop a first solution that which is merging the or the infrastructure between the blockchain and the IoT, it means many applications can be easily built on the top of this infrastructure. There are different approaches to think about which one we should use. Is it we need like a complete blockchain solution with IoT, or no, still IoT part of a solution, blockchain as a part of solution of IoT, or could be a hybrid? I just classify the different approaches, or what I call them the convergence approaches, into IoT, or IoT blockchain, and then the hybrid solution. So if I will think about the first approach, it means IoT devices usually will communicate with each other via the discovery and routing mechanism. So only a part of IoT data will be stored in the blockchain, where the other IoT interaction will take place without using the blockchain. But when can I use this approach? This kind of approach is useful only in a scenario that with reliable IoT interaction with low latency. The other approach, which I mentioned, it's the IoT blockchain, and all the interaction and their associated data will go through the blockchain in this approach, and to collect an immutable and the tracing of the record of the interaction. This approach is useful in a trade and rent scenario to obtain a kind of reliability and security. But recording all of a transaction, this will increase the bandwidth and data resource consumption. So still there is a kind of challenge in this approach. The last approach, which is hybrid, this approach, only part of interaction will take place on the blockchain, and the rest are directly shared between the IoT device. But the question, which part we have to share? This is still the challenge we have to think about it. And this approach, I can consider it as a perfect way of to leverage the benefit of both the blockchain and the real-time Internet of Things interactions. So I will draw or conclude here with some research direction, which all of us can work on this. Maybe in terms of, before I just explain the research, as we know, the Internet of Things devices, mainly the sensors, limited in terms of power processing, limited in terms of energy, in terms of bandwidth, communication, and so on. So energy efficiency has become very important once we adding here blockchain, where we'll have more transaction to handle. So better peer-to-peer communication protocol. This is one point that we have to consider. Also optimizing the hash function that it's allow the devices on IoT devices. I cannot put a large hash function. It should be acceptable hash function that it's acceptable to the limitation of the IoT devices itself. Throughput and latency, these are some also directions we have to think about it. Proposing method to manage a large amount of transaction per time unit. Optimization for transaction time should not take long time, so will not consume the energy of the devices itself. One also direction, it's how we can develop low complexity consensus algorithms. So we have to think about developing these types of agreement algorithms and with a low complexity. Block size has to be scaled to match the bandwidth limitation of the IoT networks. Could be one direction of this. We think about efficient compression technique to develop types of efficient techniques. Other one, it's in terms of the infrastructure. How can I use make it fast, for example? Make a communication protocol we mentioned, maybe better like peer-to-peer communication protocol. So maybe advanced hardware, it's not only depend on CPU. Now we have the GPUs. So let's, in our solution, to consider in the infrastructure, it's the GPUs, it's not only the CPUs. Data privacy here, all the users of blockchain are identified by their public key or its hash. So this that the privacy is not guaranteed, and since all transactions are shared, it's possible for a third party to analyze such a transaction and get the actual identity of the participants. More work is still to be done on the data privacy itself. Solution for security, like in terms of fulfilling the three security requirements: confidentiality, integrity, and availability. Still, it's an open research direction that it's need who is working on the security. So by this, I'm just sharing with you my maybe recent publication about the topic itself, about the IoT and the blockchain, using blockchain. Still, there are many projects I'm working on the same concept, but these are the most recent publications. So at this point, I would like to thank you all for attending the session, and I hope you found it useful and will be like a benefit for you, like to draw different types of research direction for your future research. So thank you.
Thank you, sir. So are we open for questions now? Any participants, if you have any questions, you can interact with sir.
Good evening, Professor. This is Murugan this side. Can you able to hear me?
Yes, I hear you. Yeah, good evening.
Thanks for your clear, what you call it, as if we felt like we are practically working on step by step you had given. Even though we had a Hyperledger practice session and everything, it gives a big level picture and everything. Thanks for your excellent presentation. My question is, what is the IBM relationship with Hyperledger? They also developing something, a proprietary product, or it's different from this product?
What's sorry, product? The IP?
IBM also is having a blockchain product.
Yeah, actually, to be honest with you, I'm not familiar with this, so maybe I will not be able to, answer that.
No issue, no issue. Thank you very much.
So we have a question from a participant. How about IoT, sir?
IoT, what's A refer to? Application?
जरा विचारू काय? Yes, good afternoon, sir. This is Dr. PG Naik. Am I audible, sir?
Yeah, I can hear you. Go ahead.
Yeah. So I have a basic question in blockchain.
Yes.
Is there any thumb rule that what applications are suitable to be implemented using blockchain technology? For example, suppose you have the online transaction processing system where a number of transactions is very, very large. like you have 1000 transactions per second and all. So whether it is suitable to be implemented using blockchain technology. If that is the case, like in database technology, how do you have the concurrency control and transaction management? Are they taken care of in blockchain?
Yeah, concurrency, it's already there because remember, this is a distributed solution. So concurrency is implemented. In terms of the size of transaction that can be handled per time unit, this will depend on the, as I mentioned, the main issue here that you have to consider, it's the consensus algorithms. So you have to look to the one that it will give you the whatever characteristics you want it to be exist in your solution. For example, as I mentioned, like Zookeeper can guarantee for me fault tolerance. If I am concerned about latency, which is the time and so on, then I have to go with of course, I will not take a proof of concept because this is it's consuming a lot of time and energy.
Yes, the block consists of number of transactions. So how many transactions can be there in a block? So is there any, this one, like when the new block is created and how many transactions are stored in the block?
Yeah, the block, we can define the block. I will give you a standard, but it's up to you also. Like you can define it based on the network characteristics of your solution. But the default is 128 gigabyte. This is the block size. Yeah, this is the common one. Huh?
And another question, suppose I want to purchase a land. So without this blockchain approach, I would manually find out whether that land is involved in any fraud or this one. And after that, I would complete the procedure, procure some documents, and I have to store it. If the same scenario, if you want to implement in the blockchain, what will be the end user's role?
Yeah.
How should I go about?
Yeah, you are talking about, as an end user.
Yeah, end user. So whether I become the part of the network or, how I have to.
No, this is what I called it, the external systems. Because the core network, who is involved, the participants involved in registering the land or even landscaping the land or doing surveying for the land, everything, these are the participants. Could be a government, could be the government with the different private sectors. As an user, I want to see more information about this. I should be having an application from the core blockchain solution. One of the participants, let's say the government, will allow me to query about that specific land. Without this permission, I can't do that. Like the same thing as I mentioned, if I want to buy a car, I have to open, for example, a mobile app or even desktop app, computer app that allow me to access the car dealer. So car dealer allow me to do this. Without this, I can't access and see what they have cars.
Okay, thank you, sir.
Most welcome.
So there's a question in the chat box. How do we go with blockchain solution using IoTA, which is a distributed ledger technology?
Yeah, I want to know what's IoTA. A refer to what? Can whoever wrote the question application?
It's an application, yeah.
Yeah, so how to go with the blockchain solution using IoT application? Again, all the transaction, exchanging the data between the IoT devices itself, could be validated through the smart contracts. As an application, I think the application here, it means maybe the end user. If I want, I'm putting, let's assume a security system in my house. The security system IoT. but all the data is saved into a trusted ledger, which is the blockchain solution. So if I would like to access the data itself, I need to build an application that allow me to access this. So again, the participant who is the only house in this example I'm giving will allow me or give me a permission to access the data. IoT application. If I am this is if I am just a query about my home security system, but in a different way, or a different, if I'm I can translate this question or can address this question in two different point of view, as an end user or as the homeowner. As a homeowner, I won't know now to configure the system itself, the home security system, to be in a different just a setting. So it means I have my own application which is not accessible by the end user. So in this case, I still have different types of application on different permission level or privileges that can use it. Distributed, I'm opening also the chat, maybe the comment that I have, distributed ledger across cryptocurrency. This is, you are talking about, this is not IoT. It cannot be IoT solution because this has become unpermissioned. If you are considering this concept, it's become unpermissioned. The way I explain it, development, it's for permission solution. This is clear now. Yeah, great.
Yes, sir, it's clear. Any other questions? Okay, so I think there are no more questions from the audience. So.
Okay, so thank you very much, Dr. Bahagavi. And it's my pleasure was to share the knowledge about the IoT and the blockchain technologies. And thank you again for the invitation, and I hope everybody will be safe.
Yeah, hello sir. This is Dr. Asha, head of the department.
Yeah, hi Doctor.
Yeah, thank you very much, sir, for accepting our invitation. And you've given very informative speech on convergence of blockchain and IoT. I think it has given a good message to all to build their research projects. Thank you once again. And I thank once again for accepting the invitation, Dr. Nidal Nasser. Thank you.
Thank you, Professor Aisha, for the invitation, actually. And I'm really happy to hear about these a kind of faculty development programs, which I start to now to talk about with our university to adapt these types of seminars. Given now everybody is doing online, so this will be benefit a lot of our faculty.
Yes. Research culture is improving now in everybody's life. That is why this is mandatory, sir.
True.
Thank you.
Thank you all, and I wish you also to be safe and to take care, especially on these hard days.
Thank you, Dr. Nidal Nasser. I thank Dr. Nidal Nasser for an extremely informative session where he discussed the functioning of both the blockchain and IoT, then the amalgamation of the two technologies to address the challenges of IoT using blockchain. He also gave various research perspective of this amalgamation. I think that will be extremely useful for the researchers who are part of this faculty development program. Thank you very much, sir, for accepting the invitation. And it's an honor and privilege to have you associated with this faculty development program. We look forward to more such associations with you, sir. Thank you very much.
Thank you very
sir.
much.
Thank you.
Take care.
Take care, sir. Thank you. Bye.